Jai Hind dear students, I am Dr. Preeti Mittal and here we are with the second part of the video for the chapter Light, Reflection and Refraction. In the previous video, we have seen about the mirrors, basic concepts, introduction about the light, ray diagrams, as well as we conducted some experiments to show that how images form for different positions of objects. In this video, we will be focusing basically about the numericals from light chapter. But before that, we should learn the formula as well as Cartesian sign convention. So let's start with that. I would like to say that if you like the content, please share it with your friends and help me spread knowledge, and let's make science interesting for everyone. So first, the formula. The formula to calculate the numericals related to light is 1 upon F is equal to 1 upon V plus 1 upon U. This formula is known as mirror formula. What kind of numericals are asked? Out of the three conditions, out of the three things, you could be asked to calculate any one, and the rest two will be given in the question. For example, you are given that the position of the object is this, the object is placed at this position, and the focal length is given, and you are asked to calculate the distance of the image from the mirror. So by using this formula, you can calculate this. But what is U, V and F? So U is the distance of the object from the mirror. Distance of the object from the mirror means distance of the object from the pole. All the distances are calculated from the pole. V is the distance of the image. This distance of the image is also calculated from the pole, and F is the focal length of the mirror. F is the focal length of the mirror. So U is the distance of the object, means the position of the object from the pole. V is the distance of the image from the pole, and F is the focal length. Using this mirror formula, we can calculate the position of image when focal length and object distance are given. We'll practice many numericals, and that will make all our concepts very, very clear. Next is the magnification formula. You are also asked sometimes to compare the height of the object with that of the object. Apart from that, you are also asked to calculate the height of the image when height of the object is given. Or you are asked to find the nature of the image. Nature of the image means, is the image real and inverted, or is it virtual and erect? All that could be found by using the formula of magnification, and that is height of image upon height of object, that is also equal to minus V by U for mirrors. Okay, so for mirrors, we have these two formula for magnification, either height of image upon height of object, and that is also equal to minus V by U. Okay, now how this magnification formula is important and what is this U, V and F? Let's understand this. For example, this is a mirror we have. This is a concave mirror. This is F, focus. This is center of curvature. Suppose this is the object that is placed. So the distance of the object from the pole is known as the distance of object, that is U. Now suppose the image is formed here, then the distance of the image from the pole is known as V, and this length between the pole and the focus that we always say, that is the focal length. So that is focal length represented by small f. Focus point is represented by capital F, and focal length is represented by small f. Okay, small case f. Now हमको अगर कोई भी न्यूमेरिकल सॉल्व करने हैं राइट चैप्टर के, तो ये मैग्निफिकेशन की वैल्यू हमारे लिए बहुत इंपॉर्टेंट रहेगी. हाउ इट्स इंपॉर्टेंट? मैग्निफिकेशन की वैल्यू आपको आपके इमेज के बारे में बहुत कुछ बताती है. लेट मी टेल यू हाउ. If the value of magnification is more than 1, that means that the image form is enlarged. If the answer of magnification is more than 1, it could be 1.5, 2, 3, कुछ भी अगर 1 से बड़ा नंबर है, then it means आपकी इमेज कैसी बनी है? enlarged है. ऑब्जेक्ट से बड़ी है इमेज. अगर आपका मैग्निफिकेशन का आंसर लेस देन 1 आता है, that shows that the image is smaller than the object. इमेज का साइज छोटा है as compared to that of object. That is shown by the answer of magnification being less than 1. अगर मैग्निफिकेशन का आंसर आपका पॉजिटिव आता है, that shows that the image is virtual and erect. अगर इमेज वर्चुअल इरेक्ट बन रही है तो आपका मैग्निफिकेशन का आंसर पॉजिटिव आएगा, एंड अगर मैग्निफिकेशन का आंसर आपका नेगेटिव आता है, that shows that the image is real inverted. So magnification value will tell you everything about the image. whether it is bigger than the object, whether it is smaller than the object, if it is real or inverted या virtual and erect. ये सब बातें हमें पता चल जाएगी किससे? मैग्निफिकेशन कैलकुलेट करके. सपोज आपका मैग्निफिकेशन का आंसर आता है -3. सपोज द आंसर ऑफ मैग्निफिकेशन इज -3. तो आप इसमें माइनस साइन को सेपरेटली कंसिडर करेंगे एंड 3 नंबर को सेपरेटली इवेल्युएट करेंगे. मतलब 3 का क्या मतलब है? नंबर 3 इज मोर देन 1. तो इमेज कैसी है? एनलार्ज्ड है. और माइनस साइन क्या शो करता है कि इमेज कैसी बनी है? रियल इन्वर्टेड. तो अगर मैग्निफिकेशन का आंसर -3 है तो इसका मतलब ये नहीं है कि -3 तो 1 से छोटा हुआ. नहीं, हम माइनस साइन को सेपरेटली वर्कआउट करेंगे और आंसर जो आया है, जो वैल्यू है, उसको सेपरेटली कंसिडर करेंगे. तो नेगेटिव साइन ये शो करेगा कि इमेज रियल इन्वर्टेड है एंड नंबर 3 इज मोर देन नंबर 1. तो इसलिए इमेज कैसी है? एनलार्ज्ड. अगर मैग्निफिकेशन का आंसर आपका आता है 0.25, तो ये आपको क्या बताता है? दैट द इमेज फॉर्म्ड इज वर्चुअल, इरेक्ट एंड डिमिनिश्ड, मींस स्मॉलर देन द ऑब्जेक्ट. इमेज का साइज ऑब्जेक्ट के साइज में के कंपैरिजन में छोटा है. ओके, ये चीजें हमारी और क्लियर हो जाएंगी जब हम बहुत सारे न्यूमेरिकल्स प्रैक्टिस करेंगे. बट एक बात और जो बहुत इंपॉर्टेंट है कोई भी न्यूमेरिकल सॉल्व करना स्टार्ट करने से पहले, एंड दैट इज कार्टेशियन साइन कन्वेंशन. So now let's look at what is Cartesian sign convention. But before that, if you want to take a screenshot, you can take, and I'll just shift to side. Now, I told you that to solve out the numericals, we'll require this mirror formula, which says that 1 upon f is equals to 1 upon v plus 1 upon u. And to find out magnification, we will use the formula minus v upon u, that is equal to height of image upon height of object. But how we will come to know that इमेज जो बनी है वो राइट साइड में बनी है या लेफ्ट साइड में बनी है? क्योंकि राइट साइड में बनी है तो हमें अलग साइन लेना होगा, लेफ्ट साइड में बनी है तो अलग लेना होगा. वी विल फाइंड दैट यूजिंग कार्टेशियन साइन कन्वेंशन. कार्टेशियन साइन कन्वेंशन इज वेरी सिंपल. आप सबने अपनी लाइफ में ग्राफ कभी भी सॉल्व किया है. ग्राफ में क्या होता है? जो भी वैल्यू राइट साइड में होती है दैट वैल्यू इज टेकन एज पॉजिटिव. जो भी वैल्यू लेफ्ट साइड में होती है दैट इज टेकन एज नेगेटिव. जो भी डिस्टेंस प्रिंसिपल एक्सिस के ऊपर होता है दैट इज टेकन एज पॉजिटिव, and whatever distance is there that is below the principal axis that is taken as negative. Cartesian sign convention is exactly same as that of your graph paper. Graph paper में जो भी rules आप follow करते हो वो same rules Cartesian sign convention के हैं. मतलब क्या है? अगर मान लो ये एक concave mirror है, ये जो बात है Cartesian sign convention that is true for both concave and convex mirror, concave as well as convex lenses also. मिरर्स हो, लेंसेज हो, कोई भी मिरर हो, कोई भी लेंस हो, दिस कार्टेशियन साइन कन्वेंशन विल बी एप्लीकेबल टू दैट. किसी भी मिरर और लेंस के लिए आप इस कार्टेशियन साइन कन्वेंशन को यूज कर सकते हैं. अभी कार्टेशियन साइन कन्वेंशन क्या कहता है? मिरर मान लेते हैं ये कॉन्केव मिरर है, ये पोल है, यहाँ हमारा ऑब्जेक्ट रखा है. ऑब्जेक्ट क्योंकि लेफ्ट साइड में ही रखते हैं, हमेशा हमेशा याद रखना कि ऑब्जेक्ट को हमेशा लेफ्ट साइड में प्लेस करते हैं. तो ऑब्जेक्ट का डिस्टेंस किस में कैलकुलेट होगा? दैट विल बी टेकन एज नेगेटिव. तो u की वैल्यू आपकी हमेशा हो जाती है नेगेटिव, क्योंकि ऑब्जेक्ट को हमेशा रखा जाता है लेफ्ट साइड में और जो भी डिस्टेंस लेफ्ट साइड में होता है दैट इज टेकन एज नेगेटिव, जैसा कि आप ग्राफ पेपर में कहते हैं. अगर इमेज आपकी मिरर के थ्रू वर्चुअल इरेक्ट बन रही है, तो वर्चुअल इरेक्ट इमेज हम आपने देखा है मिरर के रे डायग्राम्स में कि वर्चुअल इरेक्ट इमेज मिरर्स में हमेशा राइट साइड में बनती है. तो अगर इमेज राइट साइड में बन रही है, चाहे वो एनलार्ज हो चाहे वो छोटी हो, बट जब भी इमेज राइट साइड में बनेगी तो दैट डिस्टेंस विल बी टेकन एज पॉजिटिव. तो अगर इमेज वर्चुअल इरेक्ट बन रही है, अगर इमेज मिरर यूज करके राइट साइड में बन रही है, मिरर के अंदर दिख रही है, दैट इज ट्रू फॉर एवरी पोजीशन ऑफ कॉन्वेक्स मिरर. कॉन्वेक्स मिरर में हमेशा इमेज कैसी बनेगी? दैट विल बी ऑलवेज ऑन द राइट हैंड साइड. तो इमेज डिस्टेंस क्या लेंगे? पॉजिटिव. इमेज डिस्टेंस क्या लेंगे? पॉजिटिव. इमेज डिस्टेंस पॉजिटिव मिरर्स की कंडीशन में कब आएगा? ऑलवेज फॉर विच मिरर? कॉन्वेक्स मिरर. कॉन्वेक्स मिरर के लिए v की वैल्यू हमेशा पॉजिटिव आएगी, क्योंकि इमेज हमेशा मिरर में कॉन्वेक्स मिरर में राइट साइड में बनती है. ओके, अपार्ट फ्रॉम दैट अगर हम कॉन्केव मिरर देखें तो कॉन्केव मिरर में क्या वर्चुअल इरेक्ट इमेज बनती है? यस. लास्ट कंडीशन, जब ऑब्जेक्ट को पोल और फोकस के बीच में रखा हो तो इमेज पॉजिटिव बनती है. तो v की वैल्यू पॉजिटिव कब आएगी? v की वैल्यू पॉजिटिव कॉन्केव मिरर के लिए when object is between When the object is between pole and focus for a concave mirror, then the image formed will be positive. इमेज डिस्टेंस को पॉजिटिव लेंगे. क्यों पॉजिटिव लेंगे? क्योंकि वो राइट साइड में बनती है. ठीक है. ऑब्जेक्ट डिस्टेंस हमेशा नेगेटिव होगा, चाहे कोई सा भी मिरर हो, कोई सा भी लेंस हो. ओके. इमेज अगर लेफ्ट साइड में बन रही है तो इमेज डिस्टेंस नेगेटिव लेंगे. सो इफ द इमेज इज फॉर्म लाइक दिस, तो ये इमेज डिस्टेंस क्या लिया जाएगा? नेगेटिव. तो कॉनकेव मिरर की सारी कंडीशंस के लिए, एक्सेप्ट वो लास्ट वाली कंडीशन जब ऑब्जेक्ट को बहुत पास में रखते हैं बिटवीन पोल एंड फोकस, उसके अलावा जब भी हम इमेज लेंगे कॉनकेव मिरर की, दैट विल बी टेकन एज नेगेटिव. क्योंकि कॉनकेव मिरर में हमने एक्सपेरिमेंट्स के थ्रू भी देखा है कि इमेज कहाँ बनती है, दैट इज फॉर्म्ड ऑन द स्क्रीन. वो रियल इन्वर्टेड इमेज होती है और जिस साइड मिरर रखा है उसी साइड इमेज फॉर्म होती है. तो क्योंकि वो स्क्रीन पे फॉर्म हो रही है इमेज, हमेशा मिरर के सामने फॉर्म हो रही है, एंड दैट इज व्हाई वी टेक इमेज डिस्टेंस एज नेगेटिव. रे डायग्राम्स में हमेशा हमारी इमेज लेफ्ट साइड में बन रही थी कॉनकेव मिरर्स के लिए, तो वो डिस्टेंस लिया जाएगा नेगेटिव. फोकल लेंथ अगर हम बात करें, फोकस पॉइंट कॉनकेव मिरर का किस साइड था? पैरेलल बीम आई, कन्वर्ज हुई थी एक पॉइंट पे और हमने उसको कहा था कि ये फोकस है. तो फोकस पॉइंट कॉनकेव मिरर का लेफ्ट साइड में था, इसलिए फोकल लेंथ कॉनकेव मिरर के लिए कहाँ रहेगी? दैट विल बी टेकन एज नेगेटिव. कॉनकेव मिरर के लिए फोकल लेंथ विल बी टेकन एज नेगेटिव. कॉन्वेक्स मिरर का फोकल लेंथ विल बी टेकन एज पॉजिटिव बिकॉज कॉन्वेक्स मिरर में फोकस पॉइंट इज ऑन द राइट साइड. ओके. फोकस पॉइंट जो है वो राइट साइड में है, इसलिए फोकल लेंथ कॉन्वेक्स के लिए पॉजिटिव लेंगे. ये हमेशा के लिए याद रख लो, कोई नींद में भी उठा के पूछ ले तो आपको पता होना चाहिए. कॉनकेव मतलब नेगेटिव, कॉन्वेक्स मतलब पॉजिटिव. ओके. कॉनकेव नेगेटिव, कॉन्वेक्स पॉजिटिव, दैट इज वी आर टॉकिंग अबाउट फोकल लेंथ. ऑब्जेक्ट डिस्टेंस ऑलवेज नेगेटिव. इमेज डिस्टेंस नेगेटिव अगर रियल इन्वर्टेड इमेज है इन केस ऑफ मिरर, बिकॉज रियल इन्वर्टेड इमेज हमेशा लेफ्ट साइड में बनती है, और अगर वर्चुअल इरेट इमेज है तो वर्चुअल इरेट इमेज हमेशा राइट साइड में बनती है, तो इमेज डिस्टेंस विल बी टेकन एज पॉजिटिव. नाउ इमेज अगर प्रिंसिपल एक्सिस के ऊपर है, ऑब्जेक्ट हमेशा प्रिंसिपल एक्सिस के ऊपर ही रखते हैं, तो ऑब्जेक्ट डिस्टेंस जो होता है, हाइट ऑफ ऑब्जेक्ट होता है, वो हमेशा लिया जाता है पॉजिटिव, क्योंकि ऑब्जेक्ट को आप हमेशा प्रिंसिपल एक्सिस के ऊपर ही रखते हो. बट इमेज अगर प्रिंसिपल एक्सिस के ऊपर बन रही है, मतलब सीधी बन रही है, वर्चुअल इरेक्ट बन रही है, तो उसका हाइट लिया जाएगा पॉजिटिव. बट अगर हमारी इमेज इन्वर्टेड बन रही है, रियल इन्वर्टेड बन रही है, तो हाइट ऑफ इमेज विल बी टेकन एज नेगेटिव. हाइट ऑफ इमेज डज नॉट डिपेंड्स कि राइट साइड में है या लेफ्ट साइड में. जब भी इमेज प्रिंसिपल एक्सिस के ऊपर है उसकी हाइट पॉजिटिव लेंगे, जब भी इमेज प्रिंसिपल एक्सिस के नीचे बन रही है उसकी हाइट नेगेटिव लेंगे. तो हाइट ऑफ इमेज राइट या लेफ्ट पे डिपेंड नहीं करेगा, बस जो भी प्रिंसिपल एक्सिस के ऊपर होता है वो पॉजिटिव, जो भी प्रिंसिपल एक्सिस के नीचे हाइट है दैट विल बी टेकन एज नेगेटिव. और इसलिए हमने हाइट ऑफ ऑब्जेक्ट को लेफ्ट साइड में रखते हुए भी हाइट ऑफ ऑब्जेक्ट क्या लिया है? पॉजिटिव, क्योंकि वो प्रिंसिपल एक्सिस के ऊपर है. ठीक है. तो ये एक्स एक्सिस में लेफ्ट साइड नेगेटिव, राइट साइड पॉजिटिव, वाई एक्सिस में ऊपर पॉजिटिव और नीचे नेगेटिव. I hope this Cartesian sign convention is clear to you all, and we are good to go for the numericals. So you can take a screenshot if you want, and then we'll be starting a numerical. With every numerical, we will be drawing the ray diagrams also. चाहे बुक में है नहीं है, बट हम हर क्वेश्चन के साथ में, हर न्यूमेरिकल के साथ में रे डायग्राम्स प्रैक्टिस करेंगे कि उस पर्टिकुलर न्यूमेरिकल के अकॉर्डिंग रे डायग्राम कहाँ फॉर्म होगा. ओके. सो यू कैन टेक अ स्क्रीनशॉट. आई विल मूव टू साइड एंड देन we'll start with our numericals. So we have already discussed the mirror formula and the Cartesian sign convention. Now let's discuss the numericals from the chapter. Not only numericals, we are going to discuss each and every question given in your NCERT book, and then we'll practice some other extra questions as well, not mentioned in the NCERT book. So question number 1 says define principal focus. Now right now we are discussing the in-text questions which are given in the mid part of the NCERT book. So first is define principal focus. It is a point where a parallel beam of light converges or appears to converge when getting reflected from a mirror or after refraction through a lens. That point on the principal axis is known as principal focus. So this definition will hold true for a mirror as well as for a lens, because at the end of the chapter when you are performing a test, so your answers should include the concept based on mirrors as well as lenses. Question number 2, it's very easy. Radius of curvature of a spherical mirror is 20 centimeter. What is its focal length? So radius of curvature is given 20 centimeter and you are asked to calculate the focal length. So you all know that radius of curvature divided by 2 will give you the focal length. So focal length is equal to radius of curvature divided by 2. So it's very easy. 20 divided by 2, it's 10 centimeter. So the focal length will be 10 centimeter. I would like to add something extra. If there is a twist in this question and it's given that radius of curvature of a concave mirror is 20 centimeter, then what will be your answer? Then your answer will be focus is equals to minus 10 centimeter, because when they have specified that the mirror is a concave mirror, then for a concave mirror, always remember that the focal length is negative. For a concave mirror, focal length is negative, and in case it's given the question that the mirror is a concave mirror, then you have to write that the focal length will be minus 10 centimeter. Okay, first you will solve it out normally as we have done, and at last you will write, since it's a concave mirror, so the focal length will be minus 10 centimeter. Okay, in case the examiner wants to confuse you, you will not be getting any confusion. Now let's see question number 3. Name a mirror that can give an erect and enlarged image of an object. So which mirror can give you an erect and enlarged image? So that is only a concave mirror. A plane mirror will give you erect image but of the same size. A convex mirror will always give you an erect image only, but that will be always smaller than the object. So the mirror that could be used to get an erect as well as enlarged image, that is concave mirror, and that is why it's used as a shaving mirror or dentist mirror. Question number 4 says, why convex mirror is used as a rear view mirror? Rear view mirror means अगर कोई भी व्हीकल पीछे से आ रहा है तो आप उसको अपने मिरर में देख सकते हो. जो पीछे की चीजें आपको देखने में हेल्प करे, इस मिरर को बोलते हैं rear view mirror. So convex mirror is used as a rear view mirror because it forms a virtual, erect and smaller image, and there is a wider field of view. So I've shown you that in the first video that there is a wide field of view that is formed by a convex mirror, and that is why we use convex mirror as a rear view mirror. Now let's discuss two more questions given as in-text questions in your NCERT book. So the first one is, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. It's very easy. So its radius of curvature is given 32 centimeter and you are asked to calculate focal length. So you all know that focal length is half that of radius of curvature. So it's r upon 2, that is 32 upon 2, and that will make your answer as 16 centimeter. So the focal length will be 16 centimeter. Okay, so that is there. If in the question it is mentioned that it is a concave mirror, this was a convex mirror, but if it's given that it's a concave mirror, then we have to take this focal length as negative. Then at last we have to write that the focal length is going to be negative as it's a concave mirror and concave mirror has negative focal length. Okay, so I hope I'm clear with this. Just you can take a screenshot if you want, and then I'll erase the board. Now question number 2, it's a good one. A concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. So magnification is given that it is 3 times magnified. But one more thing is given, that the image is a real image. It's given 3 times magnified real image, and you all know that real image will be shown by negative magnification. That is the only thing that you need to take care before starting to do this question. And it's given that object is placed at 10 centimeter in front of it. So object distance is given as minus 10 centimeter. Why minus? Because you all know that object is always placed to the left of the pole. Okay, on the left side. So any distance that is towards the left of the pole, that is taken as negative, and so the object distance will be minus 10 centimeter. Where is the image located? You have to find out the image position. So it's very easy. You know the formula of magnification for mirrors is equals to minus V by U. Now, what's the value of magnification? It's given minus 3. That is equal to minus V upon U. The value of U is given as minus 10. Okay. Here, I can cancel out the negative. Minus minus will get cancelled to each other. So, it will become V upon 10. So, it's minus 3. That is equal to V upon 10. So, V is equals to minus 3 into 10. And that is equal to minus 30 centimeter. So, the value of position of image will be minus 30 centimeter. I'll just shift to side so they can take a screenshot. Now let's discuss the NCERT exercise questions given at the end of the chapter based on mirrors. So starting with question number 7. Before that, the questions are based on lenses. So question number 7. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. So it's given that the focal length of the mirror is 15 centimeter. Since it's a concave mirror, that will be written as minus 15. What should be the range of the distance of the object from the mirror? So you want to get an erect image using a concave mirror. Using a concave mirror, erect image will be formed only when the object is placed between pole and focus. So the distance of the object should be between 0 to 15 centimeter. Between this range, if you keep the object, then we will be getting a virtual, erect and enlarged image by a concave mirror. So next in the question they are asking that only. What should be the range? So we have specified it should be somewhere between pole to focus, that is 0 to 15 centimeter. What is the nature of the image? So nature of the image is it's a virtual erect image. And what is the size of the image? It's large. And next asks, is the image larger or smaller than the object? So obviously the image is larger than the object. So the image is going to be enlarged, or it's going to be larger than the object. Next it's asked, draw a ray diagram to show the image formation in this case. So it's very easy. We have drawn all the ray diagrams for concave mirror. And for this particular question, we need to draw the ray diagram. That was the last ray diagram that we have drawn. So it's a concave mirror. This is the principal axis. This is pole. This is focus. This is center of curvature. Always remember, whenever you are drawing any ray diagram, distance between pole and focus should be same as that between focus and center of curvature. Now, we have to place the object anywhere between pole and focus. So here I am placing my object. One of the light rays that is passing parallel to the principal axis after reflection is going to pass through the focus. So the reflected ray is going to pass through the focus. Next light ray I am going to pass through center of curvature. So another ray of light, we can see that it's striking the mirror. It's approaching towards center of curvature, but you know that any ray of light that is passing through center of curvature, it's going to retrace its path. So incident light is also this only, and the reflected light is only this only. These two are diverging light rays, so they are not going to intersect each other on the left side anywhere. But if we extend them in the backward direction on the right side, we find that they are going to intersect with each other. And the point of intersection of these light rays shows a point where the image will be formed. So the image will be formed behind the mirror, and it's going to be a virtual, erect and enlarged image. I'll just shift to side so that you can take a screenshot if you want. Now question number 8. Name the type of mirror which is used in the following situations. Headlight of a car. So in headlight of a car, we have a concave mirror, and we have discussed that this concave mirror is there and the bulb is placed at the focus. So the light rays after reflection will be going to a great distance, and we call it as that the light rays are going up to infinity. Next is rear view mirror of a vehicle. So rear view mirror of a vehicle is having convex mirror, so that a wider field of view is provided. Next is solar furnace. Solar furnace also has a concave mirror, so that the light rays could be converged to a point where the thing is kept which you want to heat. So you want a converging mirror for that purpose, and that is why solar furnace has a converging mirror, that is a concave mirror. Now next is question number 12. Between these, the questions are all based on lenses. So right now we are going to just discuss the questions given based on mirrors. Question number 12. An object is placed at a distance of 10 centimeter from a convex mirror. So object distance, it's question number 12. So object distance is given as 10 centimeter. It should be taken as minus 10 because object distance is always taken as negative. Next, focal length is 15 centimeter. It's a convex mirror and focal length will be positive for convex. Find the position and nature of the image. You have to find the position of the image, and nature of the image means you have to calculate the magnification. Whenever nature is asked, you have to calculate the magnification. Magnification tells us everything about the image. So we'll use the mirror formula. So by using mirror formula, we have, so we'll put the values. 1 upon 15 is equal to 1 upon V minus 1 upon 10, because plus and minus will become minus. Let 1 upon V be this side only because it's positive, so let it be there only. And we'll shift this minus 1 upon 10 to opposite side, so it will become plus 1 upon 10. Okay. Now we'll take the LCM of the two. So 10 and 15, the LCM is going to be 30. If you want me to take to show how we take the LCM, so it's 15 and 10 that you have learned in your junior classes. So I'll just tell you once again. In the table of 5, that 15 comes 3 times and 10 comes 2 times. Now they couldn't be divided further. No common factor is there. So we'll just multiply all the 3 and we'll get 30. So 30 is the LCM. In table of 15, 30 comes 2 times. So it's 2 times plus 10 की table में 30 आएगा 3 times में, so it's plus 3, that is 1 upon V. If you just calculate that, it comes out to be 5 and this out is 30. So it's 5 upon 30. Now we solve it out. Let's come to be 1 upon 6, but this is a value of 1 upon V. So the value of V is going to be 6 centimeter. Okay. So we have to ask to calculate the position of the object. So the position of the object is 6 centimeter. This value is positive. That shows that the image is formed on the right hand side. Okay, now we have to find the nature of the image, and nature of the image we will find by finding out the magnification. Magnification tells us about the nature of the image. Magnification formula is minus v upon u. Value of v is 6. So minus of 6 upon u is minus 10. So when we divide it, we get 0.6. Magnification doesn't has any unit. So the value of magnification is going to be 0.6. I hope it's a very easy question. It's clear to you all. I'll just shift aside so that you can take a screenshot. Now let's draw the ray diagram for the same. I told you that it's not given in the question to draw the ray diagram, but still we are going to draw that because in your exam sometimes they ask you the ray diagrams to be drawn along with the questions. So we are going to practice the ray diagrams with each and every question that we do. Next is, this is a convex mirror. For convex mirror, the ray diagram is going to be the same every time. That is the second ray diagram that we have drawn, because the object is at some distance, some specified distance is there, that is other than infinity. The object is not at infinity, it is given at some distance. So for convex mirror, we are going to draw the same ray diagram that we have drawn, the second one. So here I am drawing a convex mirror. This is showing the polished surface. This is the reflecting surface which is whirled outwards. The focal length is given to be 15 centimeter. Yeah. And the object is played at 10 centimeter distance. Okay. So we have to draw one line that is parallel to the principal axis. After reflection, it will diverge off, appear to be coming from the focus. Another ray of light, we will show that it was approaching towards center of curvature. If it would have came straight, then it would have approached to center of curvature. But still, it got reflected back, and so it will retrace its path. So whatever is the incident ray, that is the reflected ray as well. Okay, so the two rays are meeting each other at this point, and so this is the point where the image will be formed, and the image is virtual, erect and diminished. And that's what we got from our answer as well. We can just check our answer by drawing the ray diagram, that the value of v is should be coming between 0 to 15, because 15 is the focal length. So the position of the image should be less than that, and we got the same in the answer. Similarly, the magnification value should be less than 1, and it's coming less than 1. That shows that the image formed is diminished, and our image is diminished only. Next, our magnification value was positive. So that is also correct, because the image is formed above the principal axis. So by drawing the ray diagrams, we can just find out whether the answer that we have got in the numerical, that is correct or not. Okay. So I'll just shift aside. You can take a screenshot if you want. Now, question number 13. The magnification produced by a plane mirror is +1. What does this mean? Magnification produced by a plane mirror is +1. Here, plus sign shows that the image is virtual and erect, and 1 shows that the size of the image is same as that of object. So I told you, if it's more than 1, magnification is more than 1, then the image is enlarged. If the magnification value is less than 1, that shows that the image is diminished. But if it's exactly 1, that shows that the image and the object are of the same size. Why is it so? Because magnification is height of image upon height of object. So if the value of magnification is 1, that shows that height of object is equals to height of image. And that is why in this question, the image formed will be by a plane mirror will be having the same size as that of the object, and it's virtual and erect. Now question number 14, an object 5 centimeter in length. So height of the object is given 5 centimeter, is placed at a distance of 20 centimeter. Object distance is given 20 centimeter, and remember that object is always kept on the left hand side, so u is taken as negative. 20 centimeter in front of a convex mirror. Convex mirror is there, and radius of curvature is 30 centimeter. Radius of curvature is given to be 30 centimeter. If radius of curvature is 30, it's positive because it's for convex mirror. And if radius of curvature is 30, then focal length is half of this. So it's going to be 15 centimeter. Just take care that focal length is not given, radius of curvature is given. Find the position of the image, its nature and size. So we can do all that very easily. So by using mirror formula, what we'll write? By using mirror formula, 1 upon f is equals to 1 upon v plus 1 upon u. This is mirror formula. Now putting the values, 1 upon 15 is equal to 1 upon v minus 1 upon 20, because the value of u is 20. Now let v be here only because it's positive. Don't distract that. इसको इधर ही रहने देंगे. 1 upon 15 इधर है ही सही. It's minus 1 upon 20. उसको अपन opposite side shift करेंगे. It will become positive 1 upon 20. Now solve it out. 15 and 20 का LCM आता है 60. The LCM of 15 and 20 is 60. So 60 will be the LCM. 15 की table में 4 times आता है 60 and 20 की table में 3 times आता है 60. So it's 1 upon V is equal to 7 upon 60. So V is equals to 60 divided by 7. Okay, and then we have to convert it into decimals. So it comes out to be 8.57. That could be rounded up and written as 8.6, or you can leave it at 8.57 centimeter. Don't forget to write the units. If you forget to write the units, your marks would be deducted. Now, next it's asked to find out the nature and the size of the image. So nature of the image could be calculated by finding out the magnification. And you all know that magnification for mirrors is minus V by U. So magnification will be minus V minus of, what's the value of V? Now we can take 8.6, or just, it's better for calculations, just take the value in fractions only. That would make your calculations very easy. To take minus 60 upon 7, and U is given to be minus 20. So we'll just divide that. It's 3 times. So it comes out to be 3 upon 7, and that makes it 0.42. Okay, 0.42 is the magnification. That shows that the image formed is diminished. Now next is height of the image has to be found out. So you know that magnification is equals to minus V by U, and that is also equal to height of image upon height of object. So once again, placing the value, minus V by U came out to be 3 upon 7. Always better to take the values in fraction. Height of image upon height of object was given to be 5 centimeter. Let the height be here only and cross multiply the other value. So height of image is equals to 3 into 5 upon 7. So it's 15 upon 7, and that comes out to be 2.14 centimeter. Since it's height, that has to be written in centimeters only. Okay, so you can take a screenshot. I'll just shift to side. The ray diagram for this question is going to be the same as that for question number 12, because it is also a convex mirror, and I told you in convex mirror, for every answer the ray diagram is going to be the same only. Okay, now let's practice question number 15. This is the last question from the mirrors section given in your NCERT book. So its question is, an object of size 7 centimeter, means height of the object is 7 centimeter, is placed 27 centimeter in front of a concave mirror. So the position of object is 27 centimeter, and the mirror uses a concave mirror of focal length 18 centimeters. Since it's a concave mirror, so the focal length will be negative. I told you, caves के अंदर बहुत negativity है. So always remember that a cave means focal length will be negative. Concave mirror में भी और concave lens में भी. At what distance from the mirror the screen should be placed? कितनी दूर पे स्क्रीन प्लेस करना है, मतलब हमें क्या फाइंड करना है? पोजीशन ऑफ द इमेज. जहां पर इमेज बनेगी वहीं पर हम अपनी स्क्रीन प्लेस करेंगे. सो दैट शार्प focused image can be obtained. हमें इमेज कैसी चाहिए? एकदम sharp focus image, मतलब we have to place a screen at the position where the image will be formed. Find the size and the nature of the image. We also have to find out the size of the image, that is height of the image, as well as the nature of the image. And nature of the image is calculated by calculating the magnification. We'll use the mirror formula to this question. So we'll write by using mirror formula. And what is mirror formula? 1 upon F is equals to 1 upon V plus 1 upon U. The value of F is given minus 18. 1 upon U. U is minus 27. So plus and minus will become minus. So it's that. Now V has to be calculated. It's already positive. Let it be that side only. So we'll just let V, which is positive, on the right hand side only. Minus 1 upon 18 was already there, and minus 1 upon 27 has to be shifted to opposite side. So it will become positive. जब भी हम opposite side shift करते हैं तो उसका sign change हो जाता है. You all know that. Okay. 18 and 27. Now you have to calculate the LCM. So 18 and 27 both come in the table of 9. 9 2s are and 9 3s are. Okay. So the LCM is going to be 54. 9 3s are 27. 27 2s are 54. So by that we can calculate the LCM, that is 54. And in the table of 18, 54 comes 3 times. So it's minus 3 plus 27 2 times is 54. So it's plus 2. And that comes out to be minus 1 upon 54. That is 1 upon V. That is the value of 1 upon V. Now V is equal to, we will reciprocate it. So it will be minus 54 centimeter. Minus 54 centimeter will be the value of V. Okay. Now we have to find out the height of the image as well as magnification. So first let's find out the magnification. You all know that magnification for mirrors is minus V by U. So always make it a habit, every time you do a numerical, always write the formula. This is the minus sign that we got in the answer, and this is the minus sign that is there in the formula. divided by u is minus 27. So minus and minus gets cancelled, but still one minus is there. So minus L will still remain, and 27 2 times is 54. So the answer is going to be minus 2. Okay, so by the value of magnification, we can understand that the image formed is going to be enlarged because it's more than 1. And since it's a minus sign, so that minus sign is showing that its image is real and inverted. So real, inverted, enlarged image will be formed. We'll see the same with the help of a ray diagram as well. Now, for this, we have to find out the height of the image as well. So you know that magnification is equals to height of image upon height of object. So magnification is minus 2, that is equal to height of image upon height of object was given 7 centimeter. So height of image is equals to 7 times minus 2. And that's going to be minus 14 centimeter. Okay, remember this minus sign is showing that the image is formed real and inverted. It is below the principal axis, so the answer is going to become in negative. Okay, so I'll just shift aside. You can take a screenshot if you want. Now let's draw a ray diagram for this question also. So it's a concave mirror. So let's draw a concave mirror. This is a polished surface and this is a reflecting surface. It's given that the focal length is 18 centimeter. So this is focal length. This is center of curvature. Focal length is given 18 centimeter. If focal length is 18 centimeter, then the center of curvature will be 36 centimeter because it's double that of focal length. Okay, radius of curvature is twice that of focal length. तो radius of curvature कितना होगा 36 centimeter. मतलब center of curvature जो हमारा है उसका distance कितना है pole से 36 centimeter. Object कहाँ रखा है? Object is placed at a distance of 27 centimeter. Now you can see कि जो 27 centimeter है वो 18 से ज़्यादा है और 36 से कम है. तो ऑब्जेक्ट कहाँ रखा है? बिटवीन सी एंड एफ. सी एंड एफ के बीच में कहीं हमारा ऑब्जेक्ट रखा हुआ है. लेट्स प्लेस दैट. One of the rays that is coming parallel to the principal axis after reflection will pass through focus. This is incident ray. We have to show an arrow. After reflection, it is going to pass through focus. तो वो focus से pass हो जाएगी. Okay. सेकेंड रे ऑफ लाइट मैं फोकस से भी पास कर सकती हूँ या फिर सेंटर ऑफ कर्वेचर से पास कर सकती हूँ. हमारे पास 4 रूल थे, 4 में से कोई भी 2 रूल यूज करके हम रे डायग्राम्स ड्रॉ कर सकते हैं. ओके, फॉर दिस रे डायग्राम लेट्स ड्रॉ इट पासिंग थ्रू फोकस. तो सेकेंड इंसिडेंट रे को फोकस से पास करवाते हैं. फोकस से पास हो रही है, रिफ्लेक्ट होने के बाद पैरेलल जाएगी प्रिंसिपल एक्सिस के. आई होप कि मेरा रे डायग्राम में वो पैरेलल बन जाए प्रिंसिपल एक्सिस के. ओके, इट्स पैरेलल टू द प्रिंसिपल एक्सिस. जहां पर 2 रिफ्लेक्टेड रेस एक दूसरे से इंटरसेक्ट करती हैं वही पॉइंट होता है जहां पर इमेज बनी है. तो इमेज यहाँ पे बनी है, उसे प्रिंसिपल एक्सिस से ज्वाइन करना है और ये रही हमारी इमेज. इमेज कहाँ बननी चाहिए? इमेज शुड बी फॉर्म बियॉन्ड सेंटर ऑफ कर्वेचर. वैसे भी जब भी ऑब्जेक्ट को फोकस और सेंटर ऑफ कर्वेचर के बीच में रखते हैं तो इमेज बियॉन्ड सेंटर ऑफ कर्वेचर फॉर्म होती है. इमेज कैसी बनेगी? एनलार्ज. यू कैन सी, कंपेयर कर सकते हो. ओके, एंड आई टोल्ड यू रे डायग्राम्स अगर आपके स्ट्रॉन्ग है तो आप अपने सारे न्यूमेरिकल्स चेक कर सकते हो. लेट्स चेक आवर न्यूमेरिकल एज वेल. तो देख सकते हो बच्चों, द आंसर फॉर वी वाज कमिंग टू बी 54 सेंटीमीटर और सही भी है. हमारा बियॉन्ड सी है, मतलब 36 से ज्यादा होना चाहिए. इमेज इन्वर्टेड है, नेगेटिव साइन मैग्निफिकेशन का है, वो शो कर रहा है कि इमेज इन्वर्टेड है. मैग्निफिकेशन की आंसर -2 है, दैट इज मोर देन 1, वो शो कर रहा है कि इमेज एनलार्ज होनी चाहिए. और हमारा रे डायग्राम भी इस बात को सपोर्ट कर रहा है कि हमारी इमेज कैसी है? एनलार्ज है. सो बाय ड्रॉइंग द रे डायग्राम्स फॉर एवरी क्वेश्चन यू कैन चेक कि आपका आंसर जो है न्यूमेरिकल में जो आ रहा है वो सही है या गलत. अगर आपका आंसर मैग्निफिकेशन का पॉजिटिव आया होता तो इमेज आपकी राइट साइड बननी चाहिए थी, बट लेफ्ट साइड इमेज बनी है. नेगेटिव आंसर आया है मैग्निफिकेशन का, दैट सपोर्ट्स कि हाँ हमने न्यूमेरिकल बिल्कुल सही करा है. आप ऐसे ही प्रैक्टिस करते रहोगे तो आपको आ जाएगा कि आप सारे रे डायग्राम्स को, सारे न्यूमेरिकल्स को रे डायग्राम्स से चेक कर सकते हो कि आपका आंसर सही है या गलत. ओके, नाउ आई विल शिफ्ट असाइड सो दैट यू कैन टेक अ स्क्रीनशॉट. So that's all for this video. We will be practicing some more questions for mirrors. We will do a lot of numerical practice, but that we'll be doing later on. So good day everyone, and just share the video with your friends and help me to spread knowledge.